In this video, we'll introduce the identity matrix and inverse matrix. For the identity matrix, it's very simple. It's written down as I. And for the matrix, the diagonal is 1. And the rest of the matrix are zeros. And this is called an identity matrix. Inverse matrix is closely related to the identity matrix. If we have a matrix A and multiply that by another matrix we call A to the power of minus 1, that equals to the identity matrix, then we call A to the power of minus 1 the inverse matrix. How to calculate the inverse matrix of a matrix? So let's look at one example. Assume we have one matrix A. It's a 3 by 3 matrix. It asks you to solve the inverse matrix. The technique we're going to use is very similar to what we've learned before, the Gauss elimination. Here, this is called Gauss-Jordan elimination method. What we do is to write the matrix A together with the identity matrix. Let's just write down A first. And the corresponding identity matrix is a 3 by 3 matrix. The aim is to convert the left-hand side matrix into an identity matrix. So what we want to do is to use the Gauss elimination to make these entries into zeros and the rest into ones. Let's start with the third row. In order to make this entry into 0, what we can do is to use row 3 minus row 1. So minus 1 minus minus 1, that's 0. 3 minus 1, that's 2. 4 minus 3, that's 1. Then on the identity matrix side, 0 minus 1 will be minus 1. 0 minus 0 will be 0. 1 minus 0 will be 1. We can also make this entry into 0. To do that, we can use row 2 minus 3 times row 1. We can also do 3 times row 3, but here we'll just use 3 times row 1 as the example. Let me bring that down slightly. 3 times minus 1 is minus 3. 3 times 1 is 3. Then 9, 3, 0, and 0. I made a mistake here. It should be plus instead of minus. So 3 plus minus 3 is equal to 0. Minus 1 plus 3 is equal to 2. 1 plus 9 is equal to 10. Then 0 plus 3 is equal to 3. 1 plus 0 is 1. 0 plus 0 is 0. We'll keep row 1 the same. This is our new matrix. Next, we want to make this entry into 0. To do that, it's pretty easy. So we can just use row 3 minus row 2. 0 minus 0, that's 0. 2 minus 2 is 0. 1 minus 10, that's minus 9. Then minus 1 minus 3, that's minus 4. 0 minus 1, that's minus 1. 1 minus 0, that's 1. For row 2, we can make this entry to be 1. To do that, we just divide the second row. We will have 0, then 1, 5, 1.5, 0.5, and 0. And let's keep the first row the same again. Let's continue. We want to make this entry into 1. So what we can do with row 3, just to divide that by minus 9. And to keep the rest of the matrix the same. Next, let's make this into 0. To do that, we can use row 2 minus 5 times row 3. What we get is row 3 is already in the form of the identity matrix. And for row 1, we can get rid of this entry by doing row 2 minus row 1. Up till now, you can see the matrix on the left looks similar to the identity matrix already. The last entry to get rid of is this one. What we can do is to use row 1 minus 2 times row 3. What we have is the following. And this part is the inverse matrix. Note, the symbol a to the power of minus 1 is not 1 over a, it means the inverse matrix. Also, for most matrix multiplications, it's not commutative. That means a multiplied by b is not equal to b multiplied by a. However, for inverse matrix, a and a inverse is equal to a inverse multiplied by a. That equals to the identity matrix. In this video, we showed you how to use the Gauss-Jordan elimination method to calculate the inverse matrix. In the next video, we'll show you how to use determinants of matrix to calculate its inverse matrix.